Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify succinic acid. Succinic acid is HOOC CH2CH2, a dicarboxylic acid with 4 carbons. Moving on to the next step. Succinic acid delta-A. When succinic acid is heated, it undergoes intramolecular dehydration, since the 2 carboxyl groups are 1,4 related and can form a 5-membered ring to give succinic anhydride, a cyclic anhydride. Moving on to the next step. Succinic anhydride NH3 delta-B. When succinic anhydride reacts with ammonia and is heated, it first forms the ammonium salt, then loses water upon heating to give succinimide, the cyclic imide, a 5-membered ring with CoNH-CO and CH2CH2 bridging. And for the final step, succinimide Br2KOH-C. This is the Hofmann-bromamide degradation, Hofmann rearrangement, applied to an imide. In the Hofmann rearrangement, an amide or imide reacts with Br2KOH to give an amine with 1 fewer carbon. For succinimide, cyclic imide with 2 carbonyl groups flanking nitrogen, the Hofmann degradation converts one of the amide carbonyls, the ring opens and 1 CO group is lost as CO2, giving beta-alanine A, 3-aminopropionic acid H2N CH2CH2 i.e. NH2CH2 CO2H. However, examining the options more carefully, option C is CH2 CO2K plus vertical bar CH2NH2, which represents the potassium salt of beta-alanine A. Since KOH is used in the reaction medium, the carboxylate would be deprotonated to give the potassium carboxylate salt. The product formed in Br2KOH conditions is the amine in basic KOH medium, so the carboxylic acid group would be deprotonated to give CO2K+, and the amine is NH2. This matches option C, the potassium salt of beta-alanine A, K plus OC CH2 NH2. Option B would require only a 2-carbon chain, glycine analog, which is inconsistent. Option A has a 4-carbon chain with terminal amine, inconsistent. Option D shows bromination product, not Hofmann product. Why other options fail? A shows a 4-carbon amino acid, beta-aminobutyric acid analog, wrong carbon count from Hofmann on succinimide. B shows only 2 carbons, glycine-like structure, wrong, succinimide Hofmann gives 3-carbon product. D shows a brominated product, not the Hofmann rearrangement amine product. Therefore, the correct answer is C. Therefore, the correct answer is option C.